Hello friends, welcome to sakalvidya.com. In our last session we have seen elastic constants. In that we have derived one formula to calculate the volumetric strain. So the formula for volumetric strain when the load is given in the direction of length. So what is the formula to calculate this strain, this volumetric strain? So sigma v is equal to delta L by L times of 1 minus 2 into mu, where delta L by L is nothing but longitudinal strain, mu is nothing but Poisson's ratio. So in today's session we are going to discuss the volumetric strain of a cylindrical rod. So in this image it is very clear that the length of this cylindrical rod is L units. So dia is of D units. Dia is of D units. So my dear students, remember, so whenever we are going to apply a tensile load, on this cylindrical rod, so whenever you are going to apply a tensile load on the cylindrical rod, so what happens exactly? There will be expansion takes place, there will be an extension takes place along the direction of length or along the direction of applied load. So which means delta L is nothing but extension. So here delta L is nothing but extension. So if you're going to correlate this question with our previous model, so there will be decrease in its diameter, which delta D is nothing but there is a decrease in its dia, or change in dia. So for example, if this is a cylindrical rod, so on this rod I want to apply a tensile load, equal tensile load. See here L is the length of this rod and D is the diameter of the circular rod. So what happens when you are going to apply a tensile load? There will be extension takes place. So there will be extension takes place. So there will be extension takes place in this circular rod. Whereas if you observe this image clearly, the diameter will be decreasing, that is nothing but delta D. So the formula to calculate the volumetric strain for a circular rod, sigma v is equal to, which is nothing but delta L by L minus 2 times of delta D by D, where delta L by L is nothing but longitudinal strain, and whereas delta D by D is nothing but lateral strain. So what is the formula to calculate the volumetric strain for the circular rod? The formula is delta L by L minus 2 times of delta D by D. So this is the formula to calculate volumetric strain. So the volumetric strain of a rectangular bar which is subjected to 3 forces which are mutually perpendicular. So this model is very, very important. So in our first model we have seen that load is applied only in the length direction. Here we are going to apply the load in x direction, even in y direction, even in z direction, which is nothing but z direction. So for your kind information, my dear students, Pz is nothing but applied load along lengthwise, so which means we are going to apply this load along the lengthwise. So next, that is Pz. So what is meant by Pz? So even it is also an applied load. So sorry, it is Py. So Py is the applied load along breadthwise. So if you observe clearly, so your load Py is going to act on the y axis. The next comes your Pz or Pz. Pz is an applied load along depthwise, along depthwise. So here see, this is the length, so this is the breadth, and this is the depth. But our first duty is to convert this load into stress by using a simple formula. So what is the formula for stress? Stress is equal to load acting per unit area, which is nothing but sigma is equal to P by A. So in similar fashion, we need to find the load along x axis, that is nothing but sigma x. So what is the formula for sigma x? So sigma x is nothing but load which is acting in the x direction Px divided by this particular area. So this particular area. So what is the formula for that? B into D. So this is the formula to find stress in x direction. So now I am going to find stress in y direction. So sigma y is equal to load acting in y direction divided by this particular area. Now I am going to multiply this particular area, which is nothing but length into breadth. So now I am going to find the stress which is acting in z direction. So sigma z is equal to load in z direction, divided by, so area of this particular region, so which is nothing but length into depth. So after getting these three mutual perpendicular stresses, which is nothing but sigma x, sigma y and sigma z, so what is our ultimate goal? Our ultimate goal is to find the volumetric strain. So the ultimate goal is to find volumetric strain. So sigma v is equal to, here, sigma x plus sigma y plus sigma z divided by Young's modulus is multiplied with 1 minus 2 times of mu. So this is a formula to calculate the volumetric strain when a rectangular bar is subjected to three mutually perpendicular loads or stresses. If stresses is given directly, we can use this formula. If load is given, our first duty is to convert the load into stress. So this is a formula to calculate the volumetric strain of a rectangular bar which is subjected to three mutual forces which are mutually perpendicular. So today we have seen the volumetric strain for a cylindrical rod, which is nothing but delta L by L minus 2 times of delta D by D. After that, we have seen the volumetric strain when the forces are acting perpendicular to each other. So sigma x plus sigma y plus sigma z divided by E times of 1 minus 2 into mu, where mu is nothing but Poisson's ratio, whereas E is nothing but Young's modulus or modulus of elasticity. So sigma x is a stress in x direction, sigma y is a stress in y direction, sigma z is a stress in z direction. Thank you.